Okay, so welcome to my YouTube Master of the Skies weather briefing show where we talk all things weather and where I try to put an interesting spin on different global weather events and also help you to better understand what's going on in the atmosphere. So today we're going to take a look at what's going on tropical wise. You guys might have heard of an intense hurricane that's currently in the Gulf of Mexico and about to make landfall in central Florida. And so we're going to be taking a look at that. We're talking about Hurricane Milton, which is a major hurricane, was just recently a Category 5 and is starting to weaken as it's approaching the central Florida coastline. But we're going to take a look at this in a little bit more detail, looking at some information from the National Hurricane Center in Miami. And just keep in mind, this is the official site for hurricane information in the subtropical Atlantic. So if you want to take a look at some official information, certainly take a look at their site, which will be able to inform you on the steps to take if you're in this storm's path. So you could see that Hurricane Milton is in the central Gulf of Mexico and approaching the central western shoreline of Florida, and it's quite an intense hurricane, and it's still a major hurricane. It's going to be causing quite a bit of problems for folks along the coast and even inland. This is the latest discussion from the National Hurricane Center. This was around 11 a.m. Eastern Daylight Time on Wednesday, October 9th, 2024. And basically, it talks about the structure of Hurricane Milton and what's going on at the present moment. And the Hurricane Center is actually fixing current intensity at 125 knots, which is about 144 miles an hour or 231 kilometers an hour. So that's pretty intense. It's slightly down from what it was before. We had quite intense 1 minute average winds around the eye and the eye wall earlier in its life, as it was just north of the Yucatan Peninsula. It was up to about 180 miles an hour, I think. And the good thing is it's starting to weaken just a little bit before it makes landfall. If we take a look at the wind history from the storm, it started out in the Bay of Campeche, and you can see that it's just skirted the northern end of the Yucatan Peninsula and now is basically making a beeline northeastwards towards the central western Florida coastline. In yellow, you could see the tropical storm force winds, and in red, the hurricane force winds in terms of its history. And currently, you could see that the storm is located where the little white dot is, with the yellow circle representing the tropical storm force winds and the red circle the hurricane force winds. And you could see that the hurricane force winds actually blow really just around the eye, and it doesn't extend that far out from the center, contrary to the tropical storm force winds, which extend much further out. And just keep in mind that these are 1 minute average winds, and you could still get hurricane force gusts even in the orange area, since instantaneous gusts can usually be quite higher than the 1 minute average. Nevertheless, the storm was actually quite small as it was north of the Yucatan Peninsula. A very small but intense hurricane, and as it's moving towards the Florida coastline, it's actually starting to grow in size. As the wind speeds in the eye wall start to diminish, the overall wind field is expanding. And so even though the highest winds that were recorded earlier in its life won't be affecting the central Florida coastline, you will get a larger area that's affected by tropical storm force winds and also hurricane force winds, as this is still a major hurricane, as it's going to be affecting the central Florida coastline. So that's the present status of the storm, and you can see that the Hurricane Center forecasts it to hit as a major hurricane, and you have hurricane warnings out all over central Florida, and tropical storm warnings to the south in southern Florida and over northern Florida. And then the hurricane is forecast to go offshore and into the subtropical Atlantic over the Gulf Stream, and then progressively transition into a post-tropical system as it exits out toward the east, just south of Bermuda over the next several days. And so even though this hurricane is in a weakening phase, a progressive weakening phase, it will still have a very intense impact on the central Florida peninsula, and then luckily, hopefully, exit quite quickly as it is taken up within the westerly jet stream over the Atlantic. You could see the tropical storm force wind probabilities as forecast by the National Hurricane Center. You could see that most of central Florida will be impacted by tropical storm force winds, and even towards the south near Lake Okeechobee, and further, even probably further southward, as well as towards Jacksonville to the north. And if you take a look at the hurricane wind probabilities, you could see that it's smaller, but still significant, especially along the coastline just south of Tampa, where the landfall is probably expected. You might have heard that there was quite an uncertainty with regards to the final track of landfall of this hurricane, whether it was going to hit just to the north of Tampa, over Tampa, or just to the south. It seems that the latest model guidance is shunning it just to the south of Tampa, which would probably be better news in terms of storm surge for the greater Tampa area. But still, extreme impacts expected over much of central western Florida due to this hurricane. So that's the winds. Now, if we take a look at the storm surge, of course, with the onshore flow ahead of the system, the biggest impact is going to be just south of where the eye makes landfall. And so right now it's looking to be just south of Tampa all the way to about Charlotte Harbor, where 9 to 13 feet of storm surge are expected, and then less as you go northward with the offshore flow, and progressively less towards South Florida as well, even though that drops off much more slowly since you still get that onshore flow component. And just keep in mind, as the storm moves inland, you'll still get an onshore flow even to the north as it exits, and so that's why you have these storm surges also to the north of the hurricane. And then, of course, on the eastern coast of Florida, as the hurricane exits, you will also get significant storm surge along the coast. So quite a storm, and if we take a look also at the expected rainfall forecast, you could see that most of the rain associated with the system will be located just north of the eye and over the northern quadrant of the hurricane, since as the storm weakens and as it makes landfall, it will be drawing in quite a bit of drier air on its backside, and that's going to be sort of limiting the extreme rainfall south of Tampa, basically, and south of Orlando. If we take a look at the greatest flash flood risk, it corresponds to the highest track of the highest rainfall totals that are expected. So really over corridor over central Florida, from Tampa east, northeast to Orlando area. Now, if we take a look at the Tropical Tidbits website, which has really excellent tropical meteorology animations in terms of satellite, also model forecasts. If we take a look at the GO16 Channel 2 visible satellite imagery animation, this is the latest animation from the hurricane. You could see that an eye is no longer visible as it's starting to weaken gradually, but it's also approaching the Tampa area very quickly. And so this is still a strong Category 4 hurricane, and may still be a Category 4 as it makes landfall. So please keep in mind that this is still a very potent storm, even though the eye is no longer visible. Now we can take a look at the enhanced infrared imagery from earlier in its life cycle, and you can see the progressive transition to sort of a weaker sort of storm in terms of the wind speed, where the circulation loses the distinct eye it had when it was still a Category 5 storm. But nonetheless, all this pent-up energy in the system just doesn't evaporate, and it's still very intense as it's moving to the northeast. Here's another representation looking at the Dvorak sort of infrared depiction. This helps hurricane meteorologists better estimate the hurricane's intensity depending on the brightness temperature of the highest cloud tops over the storm. And so here basically you have an infrared legend in terms of the temperature, and basically the colder the temperature, the more intense and better structured the hurricane is. And so you can see that the hurricane is starting to lose sort of these grayish tones and gets more into these whitish and black tones, which are sort of warmer and so less intense, which is indicative of a progressive, slowly weakening of the tropical system. You could also take a look at the water vapor imagery, and you could really see the eye when it was still a Category 5, and now it's starting to lose its eye, and as it's moving and accelerating to northeast. You could also see all this black region, which is indicative of quite a bit of dry air, which is starting to impinge on the system, especially on its southern flank, which will progressively dry out the system south of the eye. And of course, the upper level winds, which we talk about vertical wind shear, that's also increasing as the hurricane moves to the northeast. And so that's starting to disrupt the hurricane circulation and will also aid in its progressive weakening and also progressive transition into a post-tropical system as the hurricane exits the Florida coastline later on Thursday. What's also interesting maybe is to take a look at some of the aircraft reconnaissance missions that the hurricane hunters actually fly through these systems, and the hurricane hunters have been flying practically nonstop over the last few days, where you can get really important measured information with regards to winds, temperature, and pressure, so that these data can actually aid in the hurricane forecasts as the hurricane approaches the Florida coastline. And you can see on the latest one, you can see that the central pressures are up to about 932 and then 937 millibars, which is still very intense, Category 4, but less so than it was when it was earlier in the day. We were still down to the 910s about, or even 909 millibars. And these are the different passes that the hurricane hunter flies at certain elevations in the storm, and basically the more purple and white tones indicate higher wind speeds that are here in knots with the different barbs. If I zoom in, you can see it a little bit better. Basically, you're having wind barbs close to the center as the hurricane was being transpersed up to about 120 knots, and so very intense winds measured with the hurricane hunters. Now, what's also interesting to take a look at is some of their data that they make available to the public, and you can see, for example, the mean sea level pressure as the aircraft is flying through the hurricane and through the eye. And you can see that as the aircraft flies through the eye, the pressure drops precipitously all the way down to about 917 millibars, and then rapidly increases as the hurricane hunter traverses the second eye wall. And so you could see that the central pressure is really, really low at the center. And as the pressure drops very quickly, the wind increases very quickly, since the pressure gradient is going to exert force. And so you're going to get very high wind speeds, which correspond to the eye wall. And so you can see as the aircraft traverses the center of the storm, it traverses the front eye wall and then the back eye wall, and you get these peaks in winds. And so when you see these Category 4, Category 5 storms, usually the intense winds are located just around the eye and not necessarily around the entire storm, as some people may think. And so the very high wind speeds are really confined to an area around the eye, known as the eye wall. And you can see that the winds drop off quite quickly as you extend further out from each eye wall. Another important or interesting tidbit of information is the fact that since we're dealing with warm core systems, meaning that the latent heat that's actually liberated through condensation as the convection or the thunderstorms develop around the eye, makes this a warm core system. And so you could see that temperatures inside the eye are actually at least 10 and sometimes even 15 degrees warmer than they are just outside of the eye in the precipitation rain bands and also in the eye wall. And so that's quite interesting to note with these type of systems. There you go. And to explain that, you could see, if you ever see a cross-section of a hurricane, you basically have winds in the northern hemisphere flowing counterclockwise around the circulation and tightening more and more around the eye, and then actually the air circulates up and around the eye, and in doing so, air is being forced upward. You're liberating latent heat from condensation from all that hot and humid air near the surface, and so that's actually fueling the hurricane. It's basically the sort of the heat engine that's fueling the hurricane, this latent heat, and as long as you have enough warmth inside the eye, usually you have a healthy hurricane. Also, since you have sinking air in the middle of the eye, that also put some substance in, and so that actually is also going to heat up part of the eye. So you have latent heat, condensation that's heating it, and also subsiding air that's helping to compress the air and heat it to some extent as well. You can also zoom in and see that maybe a little bit more clearly as the winds circulate counterclockwise and concentrically around the eye wall, and then actually move up and above, and then exit at the top of the storm. And as it exits the top of the storm, it actually will turn clockwise, since you usually need some kind of high pressure above the storm to keep it really, really healthy and assure a good ventilation of the system aloft and above the hurricane. But you can see that this rising air really liberates this latent heat, and that's really what fuels the storm. Now, if we could take a look at the different model maps regarding Milton, you could see that it's currently just offshore and will be making landfall shortly over the Tampa Bay area, crossing the Florida Peninsula and then exiting over the Atlantic as it weakens and basically will become extratropical or post-tropical as it moves on further to the east. What's also interesting to note maybe is here is the 300 millibar forecast from the European ECMWF model, where you can see the increasing shear as the storm that you see here is moving to the northeast. It's encountering 35 to 45 knots of wind, and that's what's actually starting to weaken the circulation progressively, as hurricanes really don't like high vertical wind shear, since they really thrive in low wind shear environments. You could also see what's interesting here, as the storm moves to the northeast, you could also see those tones of brown, which represent very dry air at mid-levels that's starting to be sucked into the circulation, and will also start to evaporate part of its circulation. And that's the reason why we're expecting mostly heavy rain just to the north of the system here, and that south of Tampa and towards Fort Myers, you will be getting less precipitation because of that dry air being sucked in. Now, since it's transitioning progressively into an extratropical system, you also have to take a look at some of this evaporative process can also help accelerate some of the winds downward. We usually call that a sting jet. That happens with very intense extratropical systems where just south of the occlusion, where you have evaporation going on, that sometimes cools the air and helps to bring down some of the very strong wind speeds aloft down to the ground. So you're basically, it's sort of downward movement of momentum towards the ground, and that can usually help intensify the winds. So even though this hurricane is progressively weakening as it's moving to the east, it could still pack quite a punch, not only in terms of its tropical characteristics, but also with regards to its transitioning hybrid extratropical characteristics. So a very dangerous storm as it crosses the Florida Peninsula. And then you can also look at different hurricane models, again here from the Tropical Tidbits website. And you could see that with time, you could see this is sort of forecast radar and how the storm is forecast to make landfall. And you could see that most of the rain is located to the north of the circulation, rather dry to the south, as I've just talked about. And what's interesting is you could also take a look at whoops, nope, I just got lost there. Sorry about that. I wanted to take a look at the precip moisture and take a look at the relative humidity. And you could really see that the green tones initially, where the hurricane is really surrounded by very humid air, as you move forward, you could see that you're getting a dry air entrainment on the southern end of the system, where you get these brown tones starting to pull in, and that's basically drying out the hurricane progressively. And so you can see as the hurricane moves inland, most of the rain and most of the humidity will be confined on its northern semicircle, and south of the center of the circulation, the air will be much drier. If we take a look also at windy, now here's some other information with regards to what's going on in Europe. We're actually experiencing right now over France and western Switzerland the remnants of ex-Hurricane Kirk that was quite intense over the central subtropical Atlantic, and that was has curved out to the northeast and is now within the mid-latitude westerlies and is being advected over France with quite a bit of rain in the forecast here currently over central France and western Switzerland. Not much of a wind threat, even though if you take a look at what's going on, you could still have a 982 hectopascal millibar low, and as this low, you could see some of the winds associated with it. We had 30 to 40 knots in the Gulf de Gascogne and in over central France, and then down to 20 to 30 knots as it's exiting towards eastern France and western Switzerland. So not very intense, but still some tropical moisture associated with it, and expecting some pretty significant rains here over the next few hours as the storm exits. And you can also see some of the other tropical systems in the subtropical Atlantic. Leslie here in the central subtropical Atlantic, which is really not forecast to do much. It's quite intense, but it'll be curving out to the northeast quite quickly as well. And so this will remain a fish storm. So there you go. I think that's about it. That's all I've got for you. I hope you enjoyed the weather briefing, and I'll talk to you soon.